Hi, my name is Ann Scanello, and I'm doing a video lesson for the Seeds of Literacy group. Today's lesson is going to be on adding and subtracting positive and negative numbers. It kind of goes along with the packet called Pre-Algebra that comes from the Number Power book. And there we go. The packet that it kind of goes along with looks like this. And it kind of covers the work on pages 10 through 17. Before I even get started on how to add and subtract positive and negative numbers, I need to go over some vocabulary. And before I even do that, I just wanted to explain one of the reasons that I picked this lesson is that adding and subtracting positive and negative numbers is such a challenging skill. Frequently, when I'm working with my seed students that are in the more advanced algebra portions, they're working on the solving equations and even the quadratics and the more difficult packets. I find that they struggle with adding and subtracting numbers, positive and negative numbers. I can only find that basic skill being taught in one packet, and I just feel like I can't emphasize enough that it's really, really important to get these skills down to be successful in the later work that you have to do. Okay, so let's review some of the vocabulary. The first one is positive number. That would be any number greater than 0. When you're looking at a number line, the numbers will always be located, positive numbers will be located to the right of the 0. There are 3 ways that you're going to see positive numbers written. Typically, we just see the number written with no sign, and it's our job to understand that's positive. Sometimes you will see the positive sign put with the number. Typically, in a lesson that is specifically talking about positive and negative numbers, you will see that sign added a lot. Beyond this lesson and this packet, you probably will see the number written just like 18. Another thing that you'll see is when you've got a positive number, you'll see it written in parentheses. I call these non-traditional parentheses. In the olden days, the positive sign used to be raised up a little bit, so it would never be confused with the plus sign. Now that we're all on keyboards and there wasn't enough space on the keyboard to put a raised positive and a raised negative sign, instead, we just use the plus symbol, but we put it in parentheses to kind of designate that that number is positive 18. Next vocabulary term is negative number. That's any number less than 0. On the number line, those numbers will always be to the left of the 0. You will always see the negative numbers written one of these 2 ways, negative 18, or you'll see it in the parentheses to distinguish it from minus 18. Number line. In this lesson, we're going to talk a lot about number line models. And so this is just an example of a number line that I found. You've got the 0 in the middle. You've got the negative numbers to the left, and you've got the positive numbers to the right. I wanted to go ahead and do a little bit of number line practice because it's always a good idea to review where our numbers fall on the actual number line. Now, I went ahead and put a number line down here. The top example is actually from the packet. I added the number line that had the numbers written in. I thought it might be a little bit faster for us. And some of them are not too tough. Negative 10 is just going to be 10 jumps to the left of 0, and it's going to go right here. So I would put negative 10 right here. Negative 7 goes right here at negative 7. Negative 4.5. I find that this can be tricky for students. We can find negative 4 jumps to the left of 0, but the half, we have to go an additional half, an additional half to the left. So negative 4.5 falls between negative 4 and negative 5. And then the next one is negative 2. And then we have negative 1/4. So negative 1/4 is going to fall between 0 and negative 1. But it needs to be marked closer to the 0 than the negative 1. So if I was grading a paper and you were identifying the position of negative 1, it would need to be right about here where my arrow is. If you put negative 1/4, might have been saying that wrong. If you were putting negative 1/4 in the middle of 0 and negative 1, it would not be correct. I find a lot of students, for some reason, put negative 1/4, over here to the left of negative 1, not correct. Negative 1/4 is between 0 and negative 1, must be shown closer to 0. The next one is 1 1/2. That would fall between 1 and 2, so right about here. And then we have 5, it's right there. 8, I can't see it on my screen, but somewhere over here. And 9 3/4. You just need to make sure that you place it between the 9 and the 10. But again, because it's 3/4, it needs to be much closer to the 10 than to the 9. Okay. Our next vocabulary term is opposites. Each negative number can be paired with an opposite number. They are opposites because they are the same distance from 0 on the number line, but they will be in opposite directions. So negative 1 and positive 1 are opposites, negative 2 and positive 2 are opposites. This was an illustration that I found in the packet, that pre-algebra packet. And it's got the same illustration of the opposites down here, but they're showing you that if you were to fold over the number line at the number 0, the opposites would all exactly match up. The next vocabulary term is absolute value. This is going to be a term that helps us to speak more precisely and to compare more precisely the numbers that we're working with today. Absolute value of a number is the distance from 0 on a number line. So, for instance, a positive 3 is 3 jumps from 0, so its absolute value is 3. Negative 3 is also 3 jumps from 0, so its absolute value is also a 3. So I wanted to kind of talk about this for a second. You're going to be asked to compare lots of different numbers. And for instance, if we're comparing a positive 3 and a negative 12, you might be asked, which is the larger number? The correct answer to that is that positive 3 is a larger number than negative 12. But sometimes it's the question that we might need to tweak, because we don't always truly want to know which number is larger. What we are really asking is which has the greater absolute value, which is farther from 0. And we're going to be writing some rules in this lesson where we're going to have to pay attention to which of the two terms is farther from 0 or has the larger absolute value. In this example, the question, which has the greater absolute value? The answer is negative 12 because it's farther from 0, even though its value is smaller than a positive 3. Okay, algorithm is another vocabulary term. It's just a fancy math way to say a set of rules to perform a procedure. You've already learned algorithms for adding and subtracting fractions, multiplying fractions, long division. There was an algorithm or a set of rules that you learned in order to do the long division. So in today's lesson, we're going to be developing some algorithms that help us to add and subtract positive and negative numbers. Before we even get started, I wanted to do a pre-test because a lot of people go into this lesson thinking, oh, that's easy. We're just adding and subtracting. I've been doing that for years and years and years. And so I kind of want you thinking, I want you to try to do the problems the way you do them now, and then we'll go through the lesson, and hopefully you'll find some tips that make it a little easier to solve these problems. So I'm just going to call out each problem. In your brain, come up with the answer. So the first one is -8 plus 5 equals, so think the answer in your brain.
Oh, okay, sorry.
And it's a -3. Lana, do you want to answer? Since I actually have a person there, you could answer, or if you don't want to, I can just let you think in your brain. What would you like to do?
Oh, I just wanted to answer it, but I had it wrong.
Okay, well, you want to know what, Lana? If you have it wrong, that kind of helps me, because in my experience as a teacher, as a math teacher, most students will do these incorrectly. The addition, sometimes students will do okay with the addition, but when we get to the subtraction pretest, it's very, very tricky. If you get the problems wrong and other students get the problems wrong, it just helps your brain to understand, wow, I really need to learn this lesson and I really need to pay attention. So that's good. I love that I have someone to answer these for me. Okay, so the next one is 8 plus -5. Lana, what do you think that answer is going to be?
It would be a positive 13, because I think I'm not sure if I remember. I think the positive number, if it's higher than the negative number, that I think you go with the positive.
Lana, you have a lot of experience with the algorithm that we're going to learn, and you have a part of the algorithm memorized, but we need to tweak your thinking a little bit, because the answer is not a positive 13. On this one, it would be a positive 3. But that's okay, because you already have heard some of the algorithm, and we're going to go over that some more. Nice. Okay, the next problem is -8 plus -5. Tell me what you think that one's going to be.
It's going to be a positive. I think 2 negatives make a positive. So it'll be just the whole number 13.
And again, you've got an algorithm memorized. I'm going to tell you that algorithm is for multiplication and division. This answer is actually -13. And because you're familiar with that multiplication and division algorithm, I'm going to tell you right now, when we're working with positive and negative integers, it is much simpler to multiply and divide positive and negative numbers. That would be a really, really short video lesson. Adding and subtracting positive and negative numbers, much more tricky, much more difficult. The same way adding and subtracting fractions is much harder than multiplying or dividing fractions. Okay, let's try another one. -8 plus 15.
Ooh.
You can say skip if you want to. Like I said, I wasn't sure if I was going to have any students on today or not.
-23.
I love that you're just brave and you just go for it. But actually the answer is a positive 7. Okay, now we're going to go through the lesson. So hopefully you're thinking, oh, wow, this is trickier than I thought. Now we're going to go through the lesson. Go ahead.
So when I see what looks like an addition problem and the if it's a left number, I say left because of, left of the number line, because of the positive and the negative. So
right.
I try that again also as an opposite. So instead of really saying addition, it's really subtraction, or?
You have learned a lot about this subject, and we're going to get to that. There are times when we get to our subtraction problems, we are going to learn a way to rewrite them to be addition, because you're right, they're related terms, and we're going to get there, but we're not there yet. Okay, so give me just a minute before we get to that point.
Okay.
The first thing there, I'm going to show two strategies to solve addition problems. The first one is going to be the number line. And so I'm a visual learner, and so I like to use number lines. Even if I don't write them on my paper, I'll think them in my brain a lot. And so here was an example of one. So if your problem was 25 plus 55, take the number line, start at 25. So we always mark our starting point. And then we need to go positive 55. And positive is traveling in the right direction to the right. So if I did 55 jumps, I would end up at 80. Now, this is a different problem, 80 plus a negative 55. 80 is my starting point, so that's where I always start on my number line at the 80 now. This time I have to travel a negative 55. So instead of traveling to the right, this time I have to travel to the left. And I'm going to go, I used to tell some of my students, do bunny hops. I would have to do 55 bunny hops. Where would I end up? So if I did that, I would end up at the number positive 25. Now, personally, I don't walk around with number lines on me, but I like to use the number line model. So I will write something that I call the simple number line on the side of my paper. And when I'm working with students at Seeds and we're doing some of the advanced math, much higher level than this lesson, and they have to add and subtract positive and negative numbers, off to the side, I'll do this. I will draw the simple number line. I just draw the line. I always put my 0 just to kind of orient my brain. Okay, where am I compared to 0? My starting point for this problem was negative 50. So I always put my starting point, and I know that's going to be to the left of 0 because it's a negative number. And I know when I'm traveling, I'm going to be going positive 75. So I'm going to be going in the positive direction, 75 jumps. So I'm here and I know I'm going to be traveling to the right. And the first thing I ask myself, let me see, this is negative 50, that's 0. If I go 75 jumps, will I make it back to 0 or will I be past 0? So 75, yeah, I will. I'll be past 0. So that tells me, wow, my answer is going to be a positive number. And then I'm good at counting by 25. Some people can count by 5s or 10s. I'm going to count by 25s on this one. So if I went negative 50 and I'm starting at negative 50, I have to go plus 75. That would be negative 25 right there. And then 0, and then I need one more jump to get to 75. And that would be a positive 25. So I'm going to do jumps of, I jumped 25, whoops, sorry. I jumped 25, I jumped another 25, I jumped a third 25 for a total of 75. So my answer then is 25. Here's another simple number line model. I always put my 0 and I have my basic number line. I don't fill in the rest of the numbers because it's not practical. I put my 105 in a reasonable position. And this time I know I need to add a negative 20. So if I'm adding a negative, which way am I going to go, Lana? Am I going to go to the left or to the right? Will the numbers get smaller or will they get bigger? To the left. Excellent.
To the left.
Perfect. So if I'm at negative 105 and I go left 20 jumps, do you want to tell me where would I end up? If you were at negative 105.
85?
No,
85?
because remember, as we go left, our numbers, let me show you the example. See this number line down here? As we go farther left, the numbers appear to get larger, but it's actually their absolute values get larger. So like here was the 6, and to the -6, I'm sorry, and to the left of -6 was -7, -9, -10. So let's go back to our other problem. Okay, so here we are at -105. We know that we're going to have -110 over here somewhere, -115. If we kept going, a total of -20 jumps, what number would we be at, Lana?
125.
You are awesome, except for tweak that just a little bit. You said 125. How would we correctly say that?
-125.
Perfect. Absolutely perfect. And those are the mistakes. Students say that all the time. They're like, I said 125. It's all the same difference. It really isn't. Saying a negative and saying a positive, two completely different numbers. But excellent job. We would be at -125. Okay. So now I wanted to kind of demonstrate some problems on the basic number line up here. And I wanted to start by having us look at two groups. We've got problems in group 1 and problems in group 2. In group 1, we're always adding, like this one is a positive plus a positive. We have a negative plus a negative, positive plus a positive, negative plus a negative. So in group 1, we're always adding the same signs. So it's either positive plus a positive or negative plus a negative. And we're going to have one set of rules when we have the same sign and we're adding. Group 2 is a little different. In this group, we always have a positive plus a negative, or it might be a negative plus a positive. They've separated these two groups because there are different rules. And so we have to decide when we're adding, are we adding the same signs, like two positives or two negatives, or are we adding different signs, like one's a positive, one's a negative? Okay, we're going to start with the same signs. And we're going to use the number line model down here at the bottom. Now, my number line is partially blocked, but hopefully we'll be able to get through this. Okay, so for group 1, we're at +2, so we always start at the starting point, and we need to go +8. So Lana, are we going to be moving to the right, or are we going to be moving to the left?
To the right.
You are awesome. And if I go 8 jumps, do you want to tell me what number I would be at?
10.
You're awesome. +10, nice job. But just saying 10 is fine. It means the same thing as +10. Okay, this time we're going to start at -2. And I have to add a -8. So Lana, will I be going left or right this time?
Left.
Left is correct. And if I go 8 jumps to the left, where would I end up? Do you know?
If we go 8 jumps to the left, it would be a -10.
You're awesome. Perfect. Okay, this one is going to be off my number line, but that's okay. Most of the problems you're working will be numbers larger than 10 or smaller than -10. If we start at 8, and I can't exactly see where that is over here, mine's blocked. If we start at 8 and we move +12, we're going to be moving to the right. So Lana, do you know what that answer would be?
A +14.
Not exactly. Okay, so I wish I could. So my 8 is somewhere around here. And I actually have to take 12 jumps. So like 1, 2, 3, 4. I'm going to go off of the number line. But if I'm at 8 and I take 12 whole jumps, try again. Do you have a thought where we're going to be?
I have to draw a number line because I.
Okay, no. Don't draw the number line. Don't draw the number line. Because you could do that. When we learn the algorithm, you'll have another way where you could use your addition algorithm to solve it. So it would be a +20.
Oh, okay. Because 2 is 10 and plus it's already a 10. Okay.
That's it, exactly. And so the algorithm, the rule that we're going to learn in just a minute would have told you, oh, I could have written that out as 12 plus 8, and so I could have added that, and you would have gotten the answer. The next problem is -8 plus -12. So I can't see my -8. I think it must be 2, 3, 4, 5, 6, 7, 8. Hopefully I'm on the -8. I have to add a -12. Lana, am I going to the left or am I going to the right?
You're going to the left, and it's going to be a -20.
I think you're getting it. That's awesome. Good job. Okay, this list is a little different, and this is one of the algorithms, but actually we're not to the algorithm yet. But so this one is tricky. This one, these are much more difficult problems. Okay, so now I'm at 2, and I need to travel +2, and I need to travel -8. Lana, am I going to be going to the left or am I going to be going to the right?
You're going to be going to the left, and it's
Correct.
probably going to be a -6.
You're awesome. 1, 2, 3, 4, 5, 6, 7, 8. Absolutely, the answer is a -6. Good job. This time I'm starting at -2, and I'm adding a +8, so I'm going to the right. Lana, you want to try that problem? Where do you think we'll end up?
You said a -2?
Yes, so I'm starting at -2, and I'm going 8 jumps to the right. Where would I end up?
That's going to be the exact opposite. It's going to be a +6, or just simply 6, the whole number 6.
Perfect. That's it. Okay, now I'm at a +8, which might be somewhere over here. I'm going -12. Am I going to go left or right, Lana?
You're going to go left. You're going to start on the right side, but then
I'm going to start at the 8, which is maybe over here somewhere, and I'm going to go 12 jumps to the left. Where am I going to end up?
A -4. This is interesting.
Yeah, and this was the algorithm we're going to learn for this. That was part of the algorithm that you were telling me a few minutes ago on the pretest. So this one is -8. So we're going to start here, and we're going to go 12 jumps to the right this time. Lana, where would we end up?
It's going to be the opposite. It's going to be a +4.
Absolutely correct. Okay. So now we've talked about the number line model, how to demonstrate it on a number line, but some people, they actually do better just memorizing the rules. And I tell students, write the rules down, and when you're working addition and subtraction problems, take out your piece of paper with the notes and use those notes and check yourself, because I can't tell you enough how many times these skills have kept people from being successful in the more advanced packets. Okay, so we can write a set of rules. When we're adding numbers that have the same sign, it might be 2 positives, it might be 2 negatives. Might be 2 positives, might be 2 negatives. We just add the absolute values, and we keep the same sign. So a positive plus a positive, we'll have a positive answer, and we just add the absolute values. Negative plus a negative is always going to have a negative answer. Now, if we have a positive plus a negative, or a negative plus a positive, instead of adding, we're going to subtract the absolute values. And that's when, you'd heard of that and you were familiar with that. The only time we subtract the absolute values when it's an addition problem is when the two signs are different. And once we've done that, we take the sign of the larger absolute value. So we're going to practice that. We're going to do the same problems, but this time we're going to be using the algorithm to do them. So this first group, let me see. So this is positive plus a positive, or negative plus a negative. So we would just add the absolute values. So Lana, what does 2 plus 8 equal?
2 plus 8 equals is 10.
Nice. Positive 10, because those were both positive. So in this example, -2 plus -8, again, we would just add the absolute values. So what is 2 plus 8?
Is 10. It's a -10.
Nice, because they were both negative terms. How about 8 plus 12? What is that going to equal? Do you know?
It's a positive 20.
Awesome. How about -8 plus -12?
It's a -20.
Perfect. Okay, group 2 is a little trickier. They have different signs. One's always a positive, one's a negative. So we're actually going to subtract the two absolute values, and then we're going to keep the sign of the larger absolute value. So we said at the beginning of the lesson, absolute value means that we ignore the sign. If it's a -8, we just think about 8. And if it's a positive 2, we just think about 2. So Lana, what's the difference, or what's the distance between 8 and 2? What's the difference? 8 minus 2 would be what?
8 minus 2?
Yep.
Would be 6.
Nice.
So
go ahead.
So, but the higher number, 2 is the bigger number. So it would be a positive number.
I love that you just told me that 2 is the larger number, because that is absolutely correct. But for our algorithm, it's not which is the larger number, it's which has the larger absolute value. And absolute value means which one is farther from 0. So so what would it be, a positive or a negative?
A negative, because of the 8.
Nice, that's it. So we subtract the 8 and the 2 to get the 6, and it's going to be a negative because the -8 is farther from 0. Good job. Okay, again, -2 plus +8. Different signs, subtract for me. What's that going to be?
That would also be 6, but it would be a positive 6.
You're awesome. How about 8 and 12? Different signs, so now we have to subtract. What would that be?
That would be let me see, 8. That would be 4. That would be positive 4.
Okay, now look at this one. It's +8 plus -12. Which is farther from 0, +8 or -12?
So it would be a -4, because 12 is the farthest from the number line.
Absolutely. Absolutely. Okay, so now try -8 plus +12. Find the difference or subtract those absolute values. What's that going to be?
It would be a positive positive 4.
Perfect. Nice. Okay. In the packet, and when you get to the packet that says pre-algebra and you're doing these lessons, they had a number of algorithms written in there, and I just wanted to talk about theirs. I actually like all of the addition algorithms they had in there. They just kind of said the same thing that we just said. So their algorithms were the sum of 2 or more positive numbers is positive. It's important that you remember that sum means addition problem. Sum is the answer to an addition problem. Their next algorithm was the sum of 2 or more negative numbers is negative. Again, the answer to an addition problem of 2 negative numbers, the answer is negative. We did that. And then their big algorithm for adding was Rules for adding numbers that have the same sign: add the numbers and give the sum the same sign as the numbers. And that's virtually the same algorithm we had. Okay, now subtracting is trickier. And, you know, adding, it takes practice to get good with that. And I really do recommend that you make a note page of that addition algorithm. I'm going to show it again at the end of the lesson so you remember that. In practice, and your brain will get very good at adding. Subtracting is much more difficult for our brain to do. We have a pretest. So Lana, do you want to try to do the pretest out loud? Or we could just do it silently for like people who are watching the video later. What do you think? Do you want to try and do it out loud?
Yes.
Okay, boy, I love that you are just a go-getter. Let's do the first problem. -8 minus 5. Tell me what you think that answer is going to be.
-8 minus 5 would be a -13. And then
You are awesome. That's correct. Now let's do this one. Oh, go ahead. What were you going to say?
No, I was going to say the next one.
Okay. 8 minus a -5. Tell me what you think that one would be.
I'm kind of confused because it's in the brackets, and normally when it's in brackets, it's something that you do first.
And
so
I love, you are the perfect student right now because you have all the math rules in your brain. Usually the brackets or the parentheses means you do those operations first. But a long time ago, when I was a kid, when we wrote negative signs, we always wrote them raised. They were a little bit higher. But now that we have computer keyboards and we're typing, we use the exact same sign for subtraction as we do for negative numbers. So it gets confusing when we have to write minus a negative number. So it's just the new custom that they've been doing since the computers have been so prevalent and everyone's got them. We put these parentheses just to kind of make it clear that this number is -5. So we want to separate the negative sign from the subtraction sign. So when students are doing an order of operations problem, and a lot of them will say to me, well, PEMDAS, I have to do my parentheses first. And I'll say, that's fine. What's in your parentheses? And they'll say -5. And I'm like, great, you did it. You've done the parentheses. Your brain understands that's -5. Okay, so that problem just says 8 minus -5. What do you think the answer to that might be?
8 minus a -5, I would say that it's a -3.
Lana, it's actually a +13. Very
I still should have added.
So okay. see, you know some of these algorithms. We're just practicing them. Yep, that one's very tricky. Okay. Oh wait. I don't know what. Okay, I'm sorry. I got a message from the GoToMeeting people. Okay, let's do this problem. It's -8 minus a -5. So now I'm starting at -8. What would that answer be?
A +13. Because it looks the same as the one we just did.
No, because this one starts at -8 and this one started at +8. So they were a little bit different. Both times we subtracted -5, but our starting point here was +8. Our starting point here was -8. And so our answer this time is -3. Do you see that?
I'm confused, very confused now.
Well, now we're on the pretest here for subtraction. So we haven't learned the strategies to subtract yet. This is just that part of the lesson where most people miss these questions. And so then it's like, it tells your brain, oh, I need to pay attention to learn the rules. So let's do next. Go ahead.
But what is the difference between a -5, a -3, and a -5, and then came up with a -13. But then the other one was a -8 with subtracting -5 in parentheses. Like, this is where I'm confused at.
Okay, so let's go back to this one. And we'll look at these on the number line, or we'll look at similar problems on the number line. Lana, can you see my red circle thing?
Yes.
Okay, what number is that right there?
A +8.
Good. What number is this right here?
A -8.
Yeah, that's the difference. And in just a minute, we're going to look at the number line. Both problems, we're subtracting a -5, but we start at different positions on the number line. And that's why our answer is going to be different. And we'll do the number line here in just a second. Okay, so let's try this one. -8 minus 15. What would you think that would be?
I say -15.
No, not a -15. It's -8 minus 15, which would be like a -8 minus a +15.
It'll be what, 23?
Ooh, you are so close. Is actually a -23. But we'll look at all these. So now we're going to learn how to do the subtraction problems. And we're going to start again. We're going to break them into two groups. Group 1, we're subtracting in all of these problems, but we're always subtracting positive minus a positive or negative minus a negative. So we're going to call group 1, the signs are the same. And group 2, we always have one's a positive and one's a negative. So we're still subtracting in all of these problems, but it's always a positive minus a negative or a negative minus a positive. So we're going to start by looking at the number line and actually modeling the subtraction or some of the subtraction on the number line. And I'm going to tell you one way to think of minus or subtraction when you're looking at a number line. Minus can be thought of as do the opposite. So in my brain, I say, when I get to minus, I say do the opposite. So this first problem is +12 minus +8. So I know on the number line, I'm going to start at 12. And unfortunately, our number line doesn't have a 12 on it. But if it did, it would be someplace way over here, far to the right. Now, if I was at +12, and I need to do the opposite of +8. Before, when I was adding and I had to add +8, I went to the right. But now I'm doing the opposite of a +8. Which way would I go if I'm doing the opposite of a +8, Lana?
Left.
You're awesome. Left. So I'm way over here at 12, and I go to the left 8 jumps. Do you know what number I'm going to end up at?
0.
No, because if I'm at 12 and I'm only going, I would have to go 12 jumps to get back to 0. So I'm not quite going enough to get back to 0. If I did 8 jumps backwards, where would I end up?
4.
Nice.
You would get a +4, a whole number 4.
Perfect. Okay, so now -5. So now I'm going to be starting way over here, 2, 3. Here's -5 right here. And I have to do the opposite of going -7. So which direction do I go if I'm doing the opposite of going -7? Am I going to the left? Right. I'm going to the right. Nice. So I'm going to go 7 jumps to the right. 1, 2. Where am I going to end up?
I can't see because that thing is blocking.
Oh, I didn't know that you were getting that thing too. I'm getting that thing blocking me as well. Okay, so we're at -7. I'm sorry, here is 2, 3, 4, -5, and I'm doing 7 jumps. So 1, 2, 3, 4, 5, 6, 7. Where did I end up, Lana?
+2.
Nice. Okay, so this one, -4, so we're going to be right here. I have to do the opposite of going -2. So which direction is the opposite of -2, left or right?
Right.
So I'm going to go to the right 2 jumps. What's my answer?
Wait a minute. We're on the 4.
And you want to know what? Yeah, and I forgot to give the answer last time. You gave me the answer, and then I forgot to show the answer. You're right. We're on the third example. -4 minus a -2. So we're starting here at -4. We're going to do the opposite of going -2. So now that means we're going to go 2 jumps to the right, is what you told me.
Mm-hmm. So that's
Where am I
still
going to
be
end up? Where do I end up?
it's still a -2.
Nice. Awesome. Okay, now this time we're going to start at +2, and I have to do the opposite of a +4. So which direction do I go if I'm doing the opposite of a positive? Is that right or left?
Left.
Nice. So I'm going to do 4 jumps, going backwards. Where am I going to end up?
A -2.
Nice job. Okay, now these are the group 2 are the problems where the signs were different. We always have a positive and a negative, or a negative and a positive. The nice thing is we use the same thought process when we are on the number line. We're still just going to say the minus can be thought of as do the opposite. So in the first one, we're starting at +12, which I don't actually have on my number line, but it's way far to the right. So if I had to do the opposite of a -8, am I going to the left or the right?
Left.
Well, negative would be go to the left, make things get smaller. But now the opposite of going -8 would be going to the right. So if I'm at 20, I'm already off my chart on the right side, and I go 8 jumps farther to the right. Do you know where I'm going to end up?
I don't know where you are.
And unfortunately,
you've already added the 20, so we're just going backwards.
well, we're right here.
Mm-hmm.
And so we start off at the 12. We need to do the opposite of going -8, which means if we were on a number line and my number line isn't big enough and I didn't know, I can't actually even see part of my number line. If I was at a +12 and I had to go 8 jumps to the right, do you know what number I'd end up at?
A +4.
Except for we would be going to the right. So we're at 12 and the numbers are getting bigger. So if I went 8 jumps to the right, what would I end up at?
Okay, I'm really confused now. Because I see a +12. So I'm just saying, you know, if you added those, it would be 20. But I'm thinking I'm starting from the right with 12, or am I starting from the right with 20?
You are starting from the right. And you know, I'm going to have one of my simple number lines actually. Well, in just a minute, I think the next slide after this one is one of my simple number lines. And I wish I had a good way to show you that right now. But on the number line, we would start at the +12. And then you're right. We're going to wind up adding 8. But the way the problem reads right now is we're doing the opposite of a -8. So we're at the 12, we go 8 jumps to the right, and we're going to end up at 20. This one's actually going to be on our number line. This is a good one for us to practice. We're at the -5, which would be right here. So -5, if I do the opposite of a +7, the opposite of a positive, do I go left or right?
Left.
Nice. So I'm at -5, and if I go 7 jumps to the left, 1, 2, 3, 4, 5, and 2 more off of the end, what
12.
number? What would it be?
A -12.
Perfect.
So it's just basically adding the positive and the negative, and the bigger number is, I mean, yeah, the bigger number or the one that's closest or furthest, that determines
Your
what
brain
side.
is trying to figure out the algorithm. And so that's awesome. Your brain is working to find out a systematic way to solve these problems. And that makes tons of sense. And that's your learning method. Some people do better with a visual, but I can tell right now you'll be better with the algorithm, which we'll get to that in just a minute. Okay, on this one, we're at a -4, which is right here. We need to do the opposite of +2. So am I going left or right if I'm doing the opposite of +2?
You're going left.
Nice. So if I do 2 jumps to the left, what's my answer?
Your answer is -6. It's a -6.
That's exactly what my answer is. And now this one, my starting point is +2, and I have to do the opposite of go -4. So which direction is the opposite of -4?
It's left.
Well, -4, the negative direction would be to the left. I need to do the opposite of the negative direction. So it'll be this one.
Right.
And if I did 4 jumps to the right, what would my answer be?
It would be a +6.
Perfect. Nice. Oh, this was the algorithm. Oh, this was an algorithm that they had in the packet. And I like this algorithm. The problem is it doesn't cover, it's not going to tell you what the sign of the answer is. So I just wanted you to be aware that this algorithm's out there, but it doesn't finish the problem for you. You actually have to take more steps beyond to figure out if it's going to be a positive or a negative answer. But their algorithm says subtracting signed numbers can be thought as finding the distance between 2 points on a number line. And they had this example. So their problem was right here, 7 minus a -4. And then we'll get to this part, ignore that. So they're saying you can find the 2 numbers. Here's the 7 and here's the -4. And you find the distance between those 2 numbers. And that's going to be your answer. And the distance is 11. I just want you to be very careful, because if the problem had been -4 minus 7, we still would say, well, this is -4. I'm going to mark that. And here's +7. And so the distance between -4 and +7 is still 11. But this time our answer would have been -11. And this little algorithm they have up here doesn't help us to know if our answer is going to be positive or negative. Again, this was just another confusing example from the packet. They give you this number line model, and you're supposed to say which of these problems it represents. So because it could actually represent 2 problems, a lot of my students have been confused, because it could represent the difference, or like +2 minus a -3, but it also is showing the distance or the difference between -3 and +2. So I just wanted you, if you actually have that packet and you're going through those, just be careful on those. Okay, so I must have saved that other, anyway, we've got a simple number line coming up in a minute. We're going to get right to writing the algorithms for subtracting, and I can't see my whole, subtracting with negative numbers. So we've got two algorithms, and you can pick either one. Some of my students prefer saying add the opposite. Other students prefer keep, change, flip. And then once you've done that, so you're going to rewrite the problem, either adding the opposite, or you can say keep, change, flip. Then you're going to use your addition algorithm. So it's a little complicated. Oh, here's my example. This was -25 minus a -6. So on my simple number line, like this is what I would write on my paper. I always put my starting point, -25. I always like to have 0, so I kind of orient myself. If I'm doing the opposite of going -6, I'm actually going forward 6. I'm actually going to the right 6. And so I would end up right here, which would be about -19. Okay, but now we're going to practice the algorithm. So these are the same problems we had before, but this time, instead of thinking about the number line, we're going to say, well, I want to add the opposite. So instead of 12 minus a +8, we need to rewrite that problem as 12 plus a -8. So we turned subtraction into addition, and we did the opposite of a +8, which is -8. So now, Lana, can you answer that question? 12 plus -8. Use our addition algorithm. Signs are different.
It's a -20.
Okay, well, think about it. Our signs are different. We have a positive and a negative. So we're actually going to subtract the absolute value. So we have to subtract the 12 and 8.
Okay, so 16 is a -16.
It would be like 12 minus 8. Can you do 12 minus 8?
Yeah. Well, it'll be a -4.
4 would be 12 minus 8, but our sign is going to be, it's going to keep the sign of the larger absolute value. Which number is farther from 0? The +12 or the -8?
The +12.
Nice. So it's actually a +4. These are very tricky. Okay, so let's do this one. The first thing I want you to do is rewrite that, adding the opposite. So right now the problem is -5 minus a -7. I want you to try to rewrite that. Instead of a subtraction problem, it'll be an addition problem. And we're going to add, you'll tell me the opposite of a -7. So Lana, see if you can do that. See if you can rewrite that, adding the opposite.
Okay, so that will be a -5 plus a +7.
Perfect.
So that would be a +12.
You're close. The signs are different. We have a -5 and a +7. And can you see over here on the far right side of the screen, I have this, the addition algorithm. It tells us when the signs are different, we subtract the absolute values. It doesn't seem right to our brain because it's an addition problem that we're solving, but we have to subtract those absolute values. So what would that?
So then that would turn around and be a 2. It would be 2, a +2.
It's exactly what that would be, Lana. Perfect. Okay, let's try this one. This is really tough. That's why I said this was such an important lesson, because these skills, these are difficult for everybody. Okay, -4 minus a -2. Help me rewrite that one, but this time I want to change our wording just so you can see which one sticks with you. This time we're going to say keep, change, flip. And the way that works, keep means you always keep the starting point the same. Change means you say change subtraction to addition. And flip means you flip to the opposite. So rewrite this one, and you're going to do keep, change, flip, which is the same as add the opposite. What would it be?
So that would be a -4 plus a +2, and then that
Perfect.
would become, yeah, then that would become a -6.
It's tricky. This algorithm that I think is on the far right of the screen, it says when we're adding.
-2.
Perfect. It's just a matter of practice. Okay, so let's do the last one. +2 minus +4. Help me rewrite that one using keep, change, flip.
Okay, so that would be a +2 plus a -4.
Perfect.
So then that would be a -6.
Different signs. We've got a positive and a negative that we're adding, so we don't add the absolute values. We subtract them. Try again.
Okay, a -2.
Perfect. It's tricky. It just takes practice. This is group 2. Same thing. We're just going to use, and whatever you're comfortable with, add the opposite or keep, change, flip. So give us more practice. Okay, so help me rewrite the first one. +12 minus a -8. What would it be now?
+12 plus a +8.
Perfect. Now those signs are the same. So now we can add and keep the sign. So what's the answer going to be?
A +20.
Nice. Let's do the next one. Help me rewrite that using keep, change, flip, or add the opposite.
Okay, so that's a -5 plus a -7.
Awesome.
So that would be a net, no. That would be a negative, a -2.
This time our signs are the same. So when the signs are the same, we add the absolute values.
So it's a -12.
Perfect. Okay. How about the next one? Help me rewrite the next one.
Okay, a -4 plus a -2.
Perfect.
So then that is a -2.
Signs are the same, we add.
A -6.
That's it. Do the next one.
Okay, a +2 plus a +4.
Correct?
So then that would be a +6.
Perfect. Okay. That's all the examples we're going to go through, but there were a few things in the packet that I wanted to talk to you a little bit about, and I also wanted to kind of review some of our concepts. One of the things that was in the packet, and you see this on all kinds of tests and you see it in different programs, And they've got number line models that look a little bit different than the number line models that I did. I like to keep things simple, but you're still at times going to be asked to look at models that look like this that might be very confusing. So a lot of times on the number line models, they always want to start from the number 0. So go up to the top here. The problem they were solving was 2 plus -4. So this first line was our starting point because it's at 0. And we're going to move forward +2 to model that 2 at the beginning of the problem. And then at this point, we're adding, but we have to travel -4. So they're modeling going 4 in the negative direction. And they're showing us then that the answer would be a -2. So I believe on this problem, you were responsible for writing the equation and knowing that they were modeling that the answer was -2. So here's another one. And this time they told you the answer, but you were just supposed to write the equation. So you were supposed to know, well, I know my starting point is always 0, and we start at the top. So we started 0. They went backwards, so they traveled -2. So that's our first term, -2. And then from there, they traveled in the positive direction. So it would be plus, and they went 4 jumps. So it would be plus a +4. And we ended up right here, and our answer was a +2. So what I've written in red right here, that's actually the answer that would have gone in the blank for question number 15. Okay, so today we've gone over a lot of things. We've talked about positive numbers, negative numbers. We've looked at a lot of number line models for the visual learners. We've talked about opposites. We've talked about absolute value and algorithm. And I think I had, I want to review the algorithms. And Lana, I think it would be a great idea. I think this video is going to be posted online, or I could leave it up now and you could write it even after we turn off the recorder. This would be a really good algorithm for you to write. When we're adding, if the signs are the same, we add the absolute values. If the signs are different, we subtract the absolute values. Those are the 2 things. You just need a little more practice knowing when to add and when to subtract. So write down those notes.
And while she's writing down those notes, Anne, I'll just tell you that this should be posted on Seeds of Literacy's website by the end of the week.
Oh, fantastic. Okay.
Yeah.
Okay, and keep copying.
I'm almost finished.
Oh, you're doing fantastic.
Okay.
Did you get that one?
Yes.
Awesome. I highly recommend that when you're practicing problems like this, just have those notes sitting out. And so you can think of your answer in your head, but before you put it down officially, double check with your notes that if the signs were the same, we're going to add. If the signs are different, we're going to subtract. Now, the other algorithm we had, this one's a little simpler, and you did fantastic with this one. When we're subtracting, don't try to subtract. Always rewrite it to be an addition problem. And you can either think in your head, add the opposite to help you rewrite it, or you can think in your head, keep, change, flip, whichever one makes more sense to you. And then once you've done that, you have an addition problem, and you use that same addition algorithm that you just wrote down. So if you think it would help you, you could write down for subtraction, add the opposite or keep, change, flip. Or if you already have that one memorized, you might not need to write that one down. Got it? And I think that was it. That was it. Thank you so much, Lena. I really appreciate it.